Imagine you are looking at a vast, invisible nervous system spanning the entire globe. It operates constantly, quietly, relentlessly. It is the physical, circulatory system of the modern world. It connects the food on your table, the fuel in your car, the clothes on your back, and the device you are listening on right now. Most days, we never even notice it. Now imagine a single narrow passage of water, thousands of miles from where you're sitting, a strait bordered by desert, a canal cut through jungle, just a few miles of geography that the world has quietly agreed to treat like a highway. Then, one headline hits, shipping route at risk, no shots fired yet, no ship physically stopped, the water is still there, but the nervous system reacts anyway. In the underwriting rooms of London, risk assessors watch their screens. Algorithms recheck the geopolitical temperature and reprice war risk in minutes. Charter terms tighten. The invisible walls start closing.
And then, out on the ocean, the physical reaction begins.
It's 2 o'clock in the morning. You're standing on the bridge wing of a VLCC, a very large crude carrier. To get the scale, imagine the Empire State Building. Tip it on its side, make it float. That's what's beneath your feet. A mesmerizing scale. You're threading the el-Mandeb, the Gate of Tears. To port, the jagged coast of Yemen is hidden in blackness. To starboard East Africa and Djibouti, the water is deep. But the safe lane for a ship this size is terrifyingly narrow.
Like a tightrope. Except the rope is a shipping lane and the fall is not dramatic. It's expensive. It's slow. It's 1,000 little systems backing up at once.
Right. You're making 12 knots. Radar is a mess of blips. Ahead of you, a container ship stacked 10 stories high, electronics and car parts bound for Europe. Behind you, a bulk carrier heavy with grain heading toward the Red Sea. It feels like rush hour. Except the cars are 1,000 feet long, carrying billions of dollars of inventory. And then the routine breaks, the radio crackles. Not the bored chatter of weather reports. A voice sharp and urgent, a naval officer from a frigate a few miles ahead. Unidentified aerial system inbound, bearing 040. The drone.
A cheap Delta Wing drone, maybe built in a garage. A lawnmower engine. A warhead the size of a microwave. The drone might cost $20,000. Your ship costs $120 million. The oil in your hold might be worth another $100 million. And in the next 30 seconds, the calculus of the global economy shifts. Because the captain has to decide, right now, with imperfect information. And at the same time, everyone else is deciding too. Insurers, traders, managers, all in parallel.
Right. In this moment, the captain is deciding whether to push forward, slow down, or turn away. But at the same time, thousands of miles away, an insurance model is waking up. A trader sees a spike. A supply chain manager gets a notification. Your delivery is no longer on time. The shockwave of risk moves faster than the ships themselves. So, how can a few miles of geography reach into your wallet?
That is the $200 billion question.
Welcome to Profoundly Curious. This is Chokepoints, the narrow passages that control trade. I'm your host, Connor Hale.
And I'm your co-host, Ava Langford. A quick note before we begin. The co-host's voice for this episode is AI-generated. The research, script, editing, and production were directed by the creator.
Today we're going to look at the world map less like geography class, and more like a circuit board, where the wires cross, where the flow concentrates, and what happens when the fuse blows.
Because those wires are just our modern way of solving an ancient problem, getting stuff from where it is to where it needs to be. And when you zoom out, you realize humanity has been fighting the same enemy for thousands of years. Distance.
A brutal war against distance. If you've ever looked at a world map and thought the ocean is just open space, this is where that intuition breaks. The ocean is vast, yes, but global trade does not flow like an open ocean. It flows through pipes, through valves, through narrow places where ships are forced to converge.
So when people say choke point, they don't just mean a narrow spot on the map. They mean a place where traffic is forced to converge.
A choke point is a narrow maritime passage that became an economic necessity. It can be a natural strait between land masses or an engineered canal. The defining feature is the convergence. Massive volumes of traffic are forced through a small geographic opening because the alternatives are too long, too expensive, or too slow. The eye of the needle. And once you see trade this way, you start noticing a brutal tension in the background of everything you buy.
Capacity versus demand.
Yes. Demand is the physical volume of goods the world wants moved right now. Oil, grain, containers of electronics, raw materials.
And capacity is ships plus routes plus time plus the ability to move safely, insurably, and profitably. When demand presses against capacity, the whole system starts to back up.
And the backup isn't a metaphor. You can literally see it. Lines of ships at anchor, waiting their turn, burning fuel, and quietly turning late into expensive.
And that line has a name: throughput. A canal or strait is a machine with a daily capacity. If it can handle 50 ships a day, that's your ceiling. If more than 50 arrive per day for long enough, the backlog grows and the whole schedule starts to slip.
Which is why the world tries to build shock absorbers, anything that buys time when the pulse slows.
Buffers, storage, warehouses full of parts, tanks full of fuel, grain elevators full of grain.
But the modern system didn't exactly build buffers. It built efficiency. It's fast, it's lean, and it's brilliant. Right up until there's no slack left.
Yeah. We built a just-in-time world. Inventory is expensive. Warehouses cost money. Capital sitting on shelves is dead capital. And those goods get taxed by governments just for sitting there. So companies got lean. The ocean became the warehouse. And software got good enough to time it all.
Which is why a small disruption can feel disproportionate.
Because there is less slack, less margin. A system that runs at high efficiency usually runs with low resilience.
Okay. Before we go to examples, let's touch on scale, because global shipping is abstract until you picture the physical mass of it moving every day, whether we notice or not. The scale is hard for the human brain. Each year, on the order of 12 to 13 billion tons of cargo move across the oceans. That's tons, not pounds. Billions of tons of physical stuff in motion. And by volume, the ocean carries the majority of world trade. Which means your room is basically a museum of maritime logistics.
Right. Pick 3 random objects around you. One of them probably spent weeks on salt water. But because this system usually works, it feels like magic. And because it feels like magic, we ignore the machinery.
And the machinery carries different kinds of lifeblood. It's not just online shopping boxes. Not even close. You can group a lot of it into 3 buckets: energy, containers, and bulk commodities.
Okay, let's start with energy.
Energy is the domain of straits like Hormuz and pipelines and terminals, crude oil, refined products, liquefied natural gas. When energy flow is threatened, prices can move immediately because markets can't wait it out the same way they can with a late shipment of furniture.
And containers?
Containers are the everything store of globalization. Finished goods, electronics, clothes, furniture, machine parts. And we should define the unit you may hear in headlines. TEU, 20-foot equivalent unit, the standard container footprint. And bulk is the unglamorous stuff that keeps societies stable: grain, coal, iron ore, fertilizer, the big, heavy basics that move by the shipload and don't have easy substitutes.
And there's this 4th category that keeps showing up in geopolitics conversations: critical minerals, copper, nickel, lithium, cobalt. Not as a political slogan, as an industrial reality. Modern electronics, motors, and grid hardware require them. They're concentrated in a handful of exporter countries, and they still have to move through the same narrow geometry as everything else.
In one sentence, choke points are the geographic cheat codes of trade. Here's the thing. Once you see it, you can't unsee it.
All right, unpack that for us.
Think about what distance does. Every extra mile burns more fuel. Every extra day ties up a ship that costs hundreds of millions. Every extra week means you need more ships to move the same amount of goods. Choke points defeat distance by providing the shortest, cheapest path between major basins of the world economy.
So the shortcut becomes sacred.
Yep. And then we do something very human. We build our whole operating system around the shortcut. Ships get designed around it. Ports get built around it. Factories get scheduled around it. And once you do that, the shortcut is not a convenience anymore. It becomes a dependency.
Which is why a single ship can become a global event.
March 2021, the Ever Given.
The ship that launched 1,000 memes.
And the memes made it feel like comedy, but the physics were not funny. Picture a container ship roughly a quarter-mile long, carrying around 20,000 containers stacked like a steel city. It's transiting the Suez Canal. Wind, reduced visibility, narrow banks. The ship loses control for a moment. The bow digs into one side, the stern swings into the other, and it wedges diagonally across the canal.
And suddenly, the artery clamps shut.
For 6 days. A narrow ditch in the Egyptian desert turns into a choke on world trade. Not destroyed, not stolen, just delayed. And that's the key. The global economy can absorb some loss. What it hates is the sudden disappearance of time.
Time is the hidden currency.
Time is the hidden currency of logistics. Choke points are time machines. They keep a trip from being 40 days instead of 30. They let a ship complete one more round trip per year. And when the shortcut breaks, the cost is not just late, it is a capacity shock.
Okay, but Ever Given cleared. The line moved.
Right. Ever Given was a short, sharp demonstration. The more important story is what happens when the constraint doesn't clear in a week, when it becomes a persistent feature of the map. And that brings us to a concept that sounds like a trick, but it's real.
The route doesn't have to be physically blocked to be closed.
Exactly. A choke point can experience what we'll call a soft closure. The water is physically open, but the route becomes functionally unusable because insurers pull coverage, because premiums spike, because crews refuse to sail it, or because the company looks at the spreadsheet and says, the math does not work.
So the blockade is made of paper.
Paper, algorithms, contracts, risk models. And that's why in the cold open, the first movement wasn't the ship turning. It was the risk system repricing. The invisible wall forming first. And here's the next question everyone asks. Can you just go around? Sometimes you can. But the detour is never free. To explain why, we need one metric that captures the physics of shipping in one unit.
Ton miles. 1 ton of cargo moved 1 mile. That's the real work shipping has to do. Here's the punchline. If the world buys the same amount of stuff, but routes get longer, the work increases. Even if the number of toasters and sneakers stays the same. Because ships have to travel further to do the same job. And the supply of ships is basically fixed in the short run.
You can't conjure a new fleet overnight. A large ship takes years to build, so longer routes tie ships up longer, which reduces effective capacity, even if every ship is still floating, and we can put numbers on it.
Asia to Europe. In a normal world, a lot of container traffic goes through the Strait of Malacca, across the Indian Ocean, up through the Red Sea, through the Suez Canal, and into the Mediterranean. Roughly 10,000 nautical miles, give or take, depending on ports. Around a month at an economical speed. And if that route is too risky?
You swing south. You round the Cape of Good Hope. You add thousands of miles in roughly a week and a half, sometimes more. Then think about what that does to a weekly schedule network. It breaks the rhythm.
Okay, but I can hear the listener. So my toaster comes 10 days late. Who cares?
The listener should care because the system is scheduled. Container networks run on weekly loops. Ports assign berthing windows like airports assign landing slots. Trucks and trains and warehouses are staffed around expected arrivals. When a ship misses its slot, it often doesn't slide neatly into the next one. It can sit at anchor. Then the next ship gets delayed. Then the yard fills. Then cranes slow down. And the delay ripples outward like a line of dominoes stretching across continents.
So the sea problem becomes a land problem.
Right, and it creates a weird phenomenon. Bunching. Ships don't arrive in a steady rhythm. They arrive in clumps. Dozens show up at once, demanding berths, cranes, labor, storage, trucks, rail slots. Even excellent ports struggle to absorb surges without losing efficiency.
Here's one of those hidden mechanics: the port Tetris problem. A container yard is basically Tetris with heavy equipment. When the yard is half full, you can move boxes around easily. When the yard pushes past a high utilization threshold, efficiency collapses. You start moving 3 containers to reach the one you actually need. That consumes crane moves and time, and it turns into costs that show up on invoices. Demurrage.
Demurrage. Penalty fees charged when containers sit too long. The cargo owner pays, the clock keeps running, and nobody feels like they're in control.
And then ships try to fight the calendar.
They do. They speed up. And this is where physics shows up with a bill. A container ship cruising efficiently might run around 16 knots. To claw back time, operators push toward 20 knots. It sounds like a small change. But pushing hundreds of thousands of tons of steel through water is brutal. Resistance rises fast, exponentially. Fuel burn can jump dramatically for a relatively small schedule gain.
So you burn money to stand still.
Yes. And beyond fuel, there are compliance and regulatory costs. Certain jurisdictions impose additional pricing or reporting requirements, including emissions-related costs. The point isn't politics. The point is that rules become line items. And line items shape routes.
Let's go back to that nervous system idea, because the first twitch is often in underwriting rooms, not on the water. Insurance is the nervous system of shipping. No bank finances a $200 million vessel without it. No cargo owner ships high-value goods without it. And when a waterway becomes dangerous, the shift often happens first in spreadsheets.
Who decides a region is high risk?
There are multiple signals, but one important one comes from war risk insurance practices. Certain committees and insurers designate listed areas. When an area is listed, standard coverage often doesn't apply the same way. Operators negotiate special war risk premiums for each voyage. And those premiums can move fast. Before crises, war risk might feel like a rounding error. When attacks begin, rates can jump. And here's the math that turns risk into reality. A modern, ultra-large container ship can be valued around $200 million. 1% is $2 million. $2 million for one single transit. Not for fuel, not for crew, not for maintenance. Just for the privilege of being covered while you pass through a rectangle on a map. So the water is open, but the route is dead.
That is a soft closure. It is a closure initiated in a boardroom. But the impact on factories waiting for parts is as hard as concrete.
And it's not just humans doing the repricing anymore.
Precisely. A lot of underwriting is supported by fast automated models. The logic can be parametric. If your ship's location data shows it enters a certain zone, coverage terms change. If incident data crosses a threshold, pricing shifts. You're watching the actuarial calculations happen lightning fast.
Which is why prices can move before shortages.
Right. Expectations shift. Futures react. Inventory managers hedge and hoard. The shock wave outruns the hulls. And choke points can fail without missiles, too. Sometimes the map stays calm, and the bottleneck is inside the system. Let's separate hard choke points from soft choke points. Hard choke points are the ones you can point to on a map. Suez, Panama, Malacca, el-Mandeb, Hormuz. They're defined by rock, water depth, and geography. Soft choke points are the ones you can't touch. Insurance capacity, port labor, rail links feeding ports, cyber systems that run cranes, maintenance backlogs, dredging schedules, pilot availability.
Okay, let's look at Panama, because it surprises people. Most people picture a canal as a trench connecting two oceans, like a river you dug and filled with seawater. Panama is not that. Panama is a machine that lifts ships up over terrain and lowers them back down using locks. And those locks consume fresh water from Gatun Lake.
Yeah. Every transit uses massive volumes of fresh water that ultimately gets released to sea. So the canal's capacity depends on water supply and management. If water levels are constrained, the Canal Authority can reduce the number of daily slots and restrict draft, meaning ships must carry less cargo so they ride higher.
So you pay the full toll to move less ship.
Sometimes yes, or you sit in a queue waiting for a slot, and the pain isn't evenly distributed. For some cargo, there are substitutes. For others, the substitute is just more ocean.
Let's define substitute in plain language. If a choke point tightens, ask, can you reroute by a different mode? Or are you just taking a longer lap? For some cargo, there's a land bridge. You unload at one coast, put containers on trains, move them across. It costs more, but it's a real alternative. For other flows, there's no substitute. The alternative is time, more fuel, more days, more ships tied up. At this point, you might be thinking, so, which choke points actually matter most?
Great. Let's do a quick tour. Not a geography lesson, a mental map of the valves.
Hit me with the short list.
Start in Southeast Asia, the Strait of Malacca. It's one of the most heavily used maritime corridors in the world. It's the key artery between the Indian Ocean and the Pacific for many routes. It's also shallow in places, which matters for the biggest tankers.
So ships might have to lighten load or use another strait.
You got it. Alternatives exist, like the Sunda or Lombok Straits, but they add distance and change routing economics. Now go west, the Suez Canal, the shortcut between Asia and Europe. When Suez is constrained, the fallback is the Cape of Good Hope. That is not a little longer. That's a new geography.
Next, Bab el-Mandeb.
Bab el-Mandeb is the gateway between the Indian Ocean and the Red Sea. It's the gate that leads to Suez. If Bab el-Mandeb gets risky, traffic doesn't just avoid a strait, it potentially avoids the entire Red Sea route.
And that's when ton miles explode.
Exactly. Now jump hemispheres back to Panama, the key connector between the Atlantic and Pacific for certain flows, especially U.S. East Coast and Gulf access to Asia. When Panama is constrained, a lot of cargo reshuffles to different ports, different rail links, or takes longer sea routes.
And then, Hormuz.
Hormuz is the energy valve, a narrow passage at the mouth of the Persian Gulf. When Hormuz is threatened, markets tend to react fast because energy is foundational. You can substitute suppliers over time. But in the short run, disruptions or risk spikes show up quickly in pricing.
Before we move on, let's ground this. How do we actually know what's happening in real time? First, AIS, the Automatic Identification System. Commercial vessels broadcast identity, position, speed, and heading. It was designed for collision avoidance, but aggregated, it becomes a map of global commerce. You can see highways, you can see bottlenecks, you can see queues, you can see the line form.
Right. Second, we can see the invisible wall by watching insurance signals, listed areas, premium spikes, tightened terms. Third, we can watch freight rates, port dwell times, and delivery time measures on land. When those move with the shipping disruptions, you're not guessing anymore. And there's a darker layer here. Not everyone is operating in the clean, insured, regulated mainstream.
The shadow fleets. When countries are sanctioned, trade doesn't vanish. It adapts. A fleet of older tankers has been used to move sanctioned oil outside traditional oversight. Opaque ownership, risky ship-to-ship transfers at sea to hide origin. Sometimes AIS goes dark. And the insurance?
Often outside the standard, well-capitalized protection and indemnity clubs, which creates a nightmare scenario. A poorly maintained tanker, lightly insured or dubiously insured, has an accident in a choke point, collision, grounding, fire, and the cleanup bill lands on coastal states and taxpayers because the financial backstop doesn't perform.
So even if you don't care about geopolitics, you should care about fragility.
Precisely. This is not only about who wins, it's about how close the system runs to its limits. So here's the practical part. A headline shows up. Straight at risk. Canal restricted. Port strike. How does a listener sort noise from real system shock?
Here's a simple filter. First, what cargo? Energy moves fast in price. Bulk commodities can hit food and industrial stability. Containers hit broad consumer goods and supply chains, often with a lag. Second, how long?
A week can be a nuisance. A month starts changing corporate behavior. Persistent disruption rewires supply chains.
Third, is there an alternate?
Can ships go around? Can you switch ports? Is there a land bridge? Or is the alternate just a longer ocean lap that eats capacity?
Fourth, what does insurance say?
Ignore the press releases for a moment. Watch the risk price. That's where reality shows up first. If premiums spike or coverage tightens, the disruption is real in commercial terms.
And fifth, watch the ripple.
Look for secondary bottlenecks. A disruption in one region can create a jam thousands of miles away in the ports that suddenly receive unscheduled arrivals. A canal restriction can reshuffle commodity flows and create price stress elsewhere. The system is interconnected in ways that do not match the map in your mind.
So we end where we started. Back on that bridge wing. The drone inbound.
The captain makes a decision. Maybe he turns away. And in that exact moment, somewhere in London, a pricing model changes. Somewhere in a port schedule, a slot disappears. Somewhere in a warehouse, a manager decides to hold more inventory just in case. The world shifts, not with a single explosion, but with 1,000 small reroutes.
The geography didn't move, but the meaning of the geography did. That's the heart of choke points. They are static on a map, but dynamic in the economy. And in a world where risk prices can update faster than a ship can turn, the most valuable trait isn't pure speed, it's resilience. And then there's Hormuz, a place where the route can be open on a map and still become unusable in practice. Because when risk spikes, the first thing that moves isn't a ship, it's the price of permission, insurance, coverage, the cost of going in at all, the invisible wall.
When tensions spike around a choke point like Hormuz, ships start hearing warnings, insurers cancel or sharply reprice war risk cover, and traffic can thin fast, sometimes before anyone has physically blocked a single ship.
So next time, we zoom in.
Next episode, Hormuz. And yeah, it's as tight as it sounds. A strait about 21 miles wide at its narrowest, with shipping lanes only about 2 miles across in each direction. A geographic bottleneck so valuable that the world prices it every minute.
Thanks for listening to Profoundly Curious. You can follow the show on YouTube, Apple Podcasts, or Spotify, and we'll see you next time.